All right, question 13. Which has a higher melting point, trans or cis unsaturated fatty acids? Explain. All right, so this is a pretty short, nice, and easy question. It shouldn't take you too long to figure this one out, hopefully. All right, so what do I mean by trans and cis unsaturated fatty acids? So let's draw a fatty acid. So we have an alkane chain here with a double bond and a carboxylate head group. All right, so drawn over here, we have a trans fat on the left. On the right, this structure is going to end up being a cis fatty acid. All right, so as you can see, when we draw a trans fat, basically the lipid tail ends up being nice and straight. It can still adopt its zigzag type conformation. All right, so the tail of a trans fat is more or less a linear structure. Anytime we have a cis double bond, right, it introduces a kink into the structure of that fatty acid. All right, so if we're thinking about a lipid bilayer now, composed of phospholipids that have either trans fats or cis fats. Well, the trans fats are able to pack next to one another very, very nicely, whereas the cis fats can't because of these the bends basically created by the double bonds. All right, if we're thinking about making a solid, all right, these fatty acids on the left here, the trans ones, are easier to pack together. All right, so molecular packing is necessary to introduce intermolecular contacts that will then lead to the formation of a crystalline solid type structure. All right, so if this form is easier to pack, that means it can pack at higher temperatures, basically, which means that the melting temperature is high. All right, conversely, these ones are going to need to go to much lower temperatures in order for them to be able to pack next to one another. All right, so as a result, their melting temperature is going to be very, very low.